Electronic Control and Digital Electronics, Level 2. Module 3, Session 3.1. Session 3.1 will cover the following content: Integrated Circuits, Subject Outcome 1.7, Transducers, Subject Outcome 4.1. Integrated circuits are the cornerstone of modern electronics. They are the little black chips that you see in just about every circuit and can be considered the heart and brains of most circuits. Almost all electronics design engineers will have at least one IC in every project they build, so it's important that you and your students understand them inside out. An IC is a collection of electronic components, resistors, transistors, capacitors, and so on, all packed together onto a tiny chip and connected in a circuit to achieve a particular end result, such as making a complete radio, cell phone, or remote control. ICs come in all sorts of shapes and sizes and are designed as single-circuit logic gates, OP amps, 555 timers, voltage regulators, motor controllers, microcontrollers, microprocessors, and many others. So, what is inside that little black chip? Let's take a look at a 555 IC, the one we will be working with in the next project. It is roughly the size of a 5-cent coin. This is what it looks like inside. Isn't that amazing? There are 22 transistors, 15 resistors, and 2 diodes in this IC. Can you imagine putting all these components on a breadboard, connecting them correctly, and getting the circuit to work? What are the advantages of integrated circuits? Integrated circuits, or ICs, are complete self-contained circuits. They have many separate components such as transistors, diodes, resistors, and capacitors etched into a tiny silicon chip. They generally do not consume large currents. There is a wide range of integrated circuits available, including timer circuits, operational amplifiers, and counter circuits, to mention just a few. ICs take up little space, allowing smaller products to be made. ICs normally cost much less to make than the individual components needed to perform the same function. They are more reliable than individual components. Easy replacement is possible because it is more economical to replace them than to repair them. So what are the disadvantages of integrated circuits? If one component in an IC fails, this means the whole circuit has to be replaced. Physically large components cannot be incorporated into an IC. It is impossible to include transformers or any other kind of inductor or large capacitor in an IC. Integrated circuits are not flexible. Their components can neither be modified nor can the parameters of operation be changed. Delicate handling is necessary as ICs cannot withstand rough handling or excessive heat. A low temperature coefficient is difficult to achieve.
This is just a simple demonstration on how easy it is to remove an integrated circuit if you have the correct tool. So this is a very, very useful tool, especially when you are working with integrated circuits, rather than using a screwdriver or anything else that may damage the component.
A transducer is a device that converts one type of energy into another. An example of a transducer is a sensor that measures a physical quantity and converts it into a signal that can be read by an observer or by an instrument. A thermocouple is a particular type of transducer that converts heat energy into electrical energy. It is therefore extremely useful for monitoring changes in temperature. Thermocouples are widely used in industry and elsewhere in everyday appliances, such as ovens and toasters or medical thermometers. Thermocouples have many advantages when compared to other forms of temperature measurement. They are small in size, and this makes them fast to respond to temperature changes. Thermocouples can measure a wide range of temperatures as well as high temperatures. Finally, they are comparatively cheap to manufacture. When combined, these advantages make thermocouples an obvious choice for many temperature measurement applications. So how does a thermocouple work? When two different conductors are joined at one end and a source of heat is applied to this junction, a small voltage, measured in milliamperes, is produced or induced in these conductors. Teaching the theory of transducers and thermocouples is all well and good, but if you want your students to understand the principles fully, they need to handle the equipment and see the components working for themselves. We are now going to do a simple and low-cost activity using small, easy-to-find components. You can easily do this activity with your students to demonstrate how a thermocouple works. Your facilitator will pause the video now and hand out the components you need. Refer to your workbook for the detailed instructions of this practical task.
Today we're going to discuss thermocouple, which is an example of a transducer. A transducer, as you know, is any device that converts one form of energy to another. For example, mechanical to electrical, pressure to electrical, even electrical to mechanical, and so forth. There are various examples of transducers. However, our focus this afternoon is going to be on two dissimilar type of materials when joined together, which is called a thermocouple. This material has to be different from that. You could use either copper, aluminium, nichrome, steel, so long as they are two different types of material. If we heat the one end, a potential difference will appear across these 2 points here, which is called the cold end. However, you must bear in mind that the voltage that's developed across here is very, very small, as you will notice on the digital multimeter. So let's do that. I'm setting my multimeter to millivolts, DC millivolts. I'm connecting one end of my probe on the one type of material, the other end to the other type of material, and as you can see, it's 0 at the moment. When we heat it, let's notice the difference. Can you see that we are developing electricity? If I take it away, notice what happens. The voltage starts to drop, eventually goes back to 0. If I go back into the heat, that's the hot end. You can see that we are developing electricity. So that proves the concept that if you take two dissimilar materials, join them on the one end, the hot end, you can generate a small, minute potential difference on the other two ends, called the cold end. This is an example of a thermocouple.
End of the video. We'll be right back.